What I have here is a camera that's set to revolutionize the world of planetary astrophotography. And why is that? Because it features the new Sony IMX715C sensor, a color camera distinguished by having pixel sizes that are half as large as those in other planetary cameras on the market. And this means ultra-fine planetary, lunar, and solar details. My name is Miguel Azorín, and I welcome you once again to Natural Portraits. We're going to thoroughly analyze and review the new SVBony SC715C. If you're a regular follower of the channel, you'll know that planetary astrophotography is a discipline I'm passionate about. It was the first astrophotography discipline I started practicing back in 2003. And to this day, everything I know about photographing planets, the moon, or the sun is included in the Planetary Astrophotography course at the Natural Portraits Academy. It's a course that covers everything from 0, the very basics, all the way to 100, where you can learn absolutely everything related to this incredible astrophotography discipline. And the thing is, planets are alive. In the description of this video, you'll find a link where you can take a look. When I found out that SVBony was planning to launch a new planetary camera with an IMX715 sensor, I didn't hesitate to contact them and offer myself as a tester. The thing is, the smallest pixels in any planetary camera on the market are 2.9 microns in size, while the pixels in this SVBony SC715C are 1.45 microns, exactly half the size. This can mean two things. Smaller pixels usually produce noisier images. The larger the pixel size, the greater its light gathering capacity, and therefore it produces an image with more signal and less noise. Conversely, smaller pixels collect less light and less signal, so they generate noisier images. But this is not a concern in planetary imaging, because the objects we photograph generally have very high surface brightness, such as the moon, the sun, and the main planets of the solar system. The second thing, and the real reason I was interested in this camera, is that smaller pixels mean planetary images with higher resolution and more detail. This SVBony SC715C is equipped with a sensor of 3000, 840 x 2160 pixels, 8.29 megapixels, 12 bits, and a capture rate of 45 frames per second at maximum resolution, which is made possible by a 512 MB DDR3 buffer. In addition to this, the camera comes with a built-in UV-IR cut filter. It is a planetary camera that is absolutely ready to use straight out of the box and start capturing images with. It also includes an ST4 auto-guiding port. So these are the features of this new SVBony SC715C. But how does it really perform in planetary imaging? Let's find out. Alright, so here we have the moon now. I have to say, by the way, that it took me a bit of effort to adapt the camera, that is, to get it in focus with this telescope. Newtonian telescopes are somewhat peculiar when it comes to achieving focus, so I had to attach some adapters until I found the focal point. But anyway, we have the moon here now. This is the framing it gives. Notice that it gives a certain framing rate. Now I've set it to 25%. If we set it to 50%, it completely goes out of the field of view. I'm going to try to get a better focus and adjust the exposure and gain settings to get a better image. What I'm going to do is activate the ROI mode. We're going to select a smaller area to get a higher refresh rate and in this way achieve a more precise focus. But anyway, notice that in ROI mode at 640 by 480, look at the definition the camera already provides. Actually, achieving focus this way is quite simple. I'd say the focus is more or less there. I can see the details are quite sharp. Well, even though with fire capture the image was visible and we managed to focus and so on, I have to say that I had some problems, and that is that at no point was I able to get past a frame rate of 3.5 frames per second. I tried configuring fire capture in different ways and nothing worked. At no point could I get past 3.5 frames per second, which is absolutely ridiculous for this camera. There is probably some kind of incompatibility between fire capture and this camera since it is a very, very new camera. In fact, when we try to open it in fire capture, it doesn't even recognize it, and we have to install an external driver like ASCOM as an ASCOM camera. So I imagine this is something that will be resolved over time. What I did was install SVBony's native application for image capture with their own cameras. And in this case, yes, here I have a very, very smooth image from the camera. As we can see, there is some atmospheric turbulence, but here we really do have a very smooth image of what the camera is capturing. And well, honestly, the resolution is incredible. If I switch to the full frame provided by the camera, which is this one here, we can see the entire frame, but if I go to 200%, just look at the resolution this camera has. Even though, well, tonight we have some atmospheric turbulence, but right now I'm at 200%. And look at the level of detail it gives you, it's incredible. And right now I'm shooting at the native focal length of this telescope at 1200 millimeters. That is at prime focus. But just look at the level of detail we can observe in the craters, in the mountains. The resolution this camera gives us is truly incredible, and above all, the clarity of the image, because I see an image that is really very, very clean. Absolutely no noise at all. Over here, we have the Plato crater, it's right here, and the level of resolution is really very high. Keep in mind that the image we're seeing is exactly the framing we're looking at. Like most planetary cameras, the color version gives us a rather greenish image, and that's because color cameras usually have two green components in the RGB. This, as you can see, gives us a very greenish image, but normally we can adjust this from one of the camera settings. For example, right here. Alright, so here I have a white balance option that allows me to get a much more neutral image. There we have a much more neutral image. Here we have the Copernicus crater, one of the most beautiful craters on the lunar surface. Let's zoom in to 200%. Look at that, it's incredible. The level of resolution this camera has is amazing. And tonight the sim, as you can see, is quite mediocre. But even so, when we zoom into 200%, the level of detail is outstanding. We can clearly see all the details of the inner part of the crater, the terraces, all these small craters we have on this side here of Copernicus, some chains of little craters that are found over there. The sim works well at all times. At certain moments, the details are quite clear, like right now, when they look really, really sharp, but then the image quickly starts to wobble. The way to really get the most out of this type of high-resolution camera is by using Barlow lenses like the one I have here. If we combine a very high camera resolution with a very long focal length, the level of detail we can achieve on the planets, and in this case on the moon, is extremely high. Although for that we would need a night with very stable atmospheric conditions, which is not the case right now. Even so, I'm gonna give it a try. Let's set up the Barlow lens and see what we get. You can see that this is not the ideal night to use a Barlow lens, but we can already get an idea of what we could achieve with this camera and its resolution, because when shooting at prime focus, as we saw, if we zoomed in to 200%, it was almost like viewing the image through a Barlow lens. So just imagine if we have a very stable night and we can use a Barlow lens with 2, 3, or even 5 times magnification. If our equipment can handle that level of magnification, what we could achieve with a camera like this. So if, like me, you are passionate about planetary astrophotography, this camera will probably bring you a lot of satisfaction. Take a look through the link you'll find in the description of this video.